Good morning, Algebra 2. Hello, hello, hello. Who's here this morning? Who woke up on this bright, sunshiny morning that's not actually bright and sunshiny? Hey, Michael. How's it going, Michael? I feel like I didn't see y'all last week. Jade and Sarah, good morning as always. What a terrible start to the day. I don't know about you guys. I'm pretty depressed right now. It's supposed to rain like the entire day, mucky. Not a fan. But nothing like starting a day off like with some math. It's gonna be a good one. We're gonna have a good day today. How was everyone's weekend? Anyone do anything interesting, fun, creative, besides play Animal Crossing? I'm sure by now Michael's probably beat that game 4 different times. I don't know if you can even beat that game. Not really sure. No, I don't even have it. Yeah, okay, Michael. That's what they all say. Right, Jared has it, and so you just play on his. Got it. That's your way around it. Michael, remember in the beginning of the year, it took me like probably 2 weeks to figure out you and Jared were brothers? And then someone said it, and I was said, "Are you kidding me? That's for real." Hall's a pretty popular last name, so I'm gonna defend myself a little bit. You know, it's a little. You just automatically assume anyone with the last name Hall is brothers. Now, if it's Digidio, that's not as popular. So if I see multiple Digidios, I kind of have a feeling, yeah, they're probably related. And if they're 5 feet tall, it also gives it away a little bit. I'm gonna give it a couple more minutes, guys. While you guys are waiting, go to open up the calendar. So I posted the calendar to Google Classroom. Go to open that up. We're going to talk about that real quick, and then we'll get into the book. So have your book open. We're working on 12.1, as you can see in the calendar. So you can go over there. Check that out. On the contrary, this Dr. Martha Pigfoot, his name is, oh, really? Okay, but he spells it a little bit differently? Or does he spell it without the apostrophe? Is that the difference? He just spells it D-E? That'd be interesting. Morning, Damon. How you doing? How's your weekend? Yes, maybe there's more Degatios than I thought there were. All right. So calendar open, 12.1 out. Thank you for ever threw that like my way. Appreciate it. It's spelled differently. I just can't remember. Oh, okay. I got you. That's maybe it's more popular than I thought. I don't think I've ever seen anyone spell it like you guys spell it, though. Like, I don't think I've ever seen that type of spelling, which is that I think that's pretty unique. All right, 11:05. That means it's about time. Like was for me. I always can count on you, Jaden. Okay. So guys, pencils, papers out, books open, the usual. First of all, let me just say, happy Monday. Hopefully we all had good weekends. Hope you guys are staying safe, family safe, everything's going well. This week is a special week because this week is kind of the what's the wording I'm looking for? It's kind of the last stretch, I guess. And especially for most of you, I can't speak for everyone, but at least some of you, if not most of you, this will be your last week. So if you didn't know, or if you were kind of unclear on what's going on, this is going to be the last week where the teachers are actually going to be giving you guys content. So in my case, it's going to be last week I'm streaming like lesson notes and stuff to you guys. It'll be last week you learn new chapters in science, whatever the subject is. This is going to be our last time for us, like, I guess, teaching new stuff. And if you're in a good spot, then you will be pretty much done. And when I say if you're in a good spot, I don't know if it's been entirely clear exactly what the cutoff point is. I think it's kind of more towards the teacher's discretion. So what I'm looking for is 60% or above. 60% or above I'm looking for because that's considered a C. So obviously I always think it's good to push yourself to try to get a little bit higher. And for some people, maybe I'll have a conversation, but I won't be focusing very heavily on the people with 60% or higher in the class. You're passing it with a good grade as a C, so you're happy, I'm happy. Now, I want to make this clear. If you are at a position, let's say you're at an 80%, and you're like, I don't love it, and there's an assignment in the grade book that you forgot to do, and you're like, yeah, I would like to be able to do that again, I'll open that up for you. So I'm comfortable doing this because I know it's not going to be chaos. I'm not going to have a bunch of people asking me. But I know there's going to be a few people who are like, yeah, I want to see if I can get my grade up a little higher. If it's at 80% though or higher, I'm not going to do it probably. I might open it up. I don't know. We'll see. If you're really that interested, and I guess it's good to do the content. But you're at an A already, and there's no A pluses, no like weighted grade point average. So like in terms of that, there's no like I'm not going to give you any extra assignments if you already have an A in the class. I'll let you make up your work, but that's only for work that you didn't complete. So if you completed work and you missed points, that's set in stone. There's no redoing that. So I just want to make that clear. But just start looking at your grade book. I'm gonna start grading last week's work and get that a little bit updated, so you'll see even more up to date where you're at in the class. Just keep an eye on it, and then we'll go from there. Jaden, what page is 12.1? Just use the content feature, whatever it is, and just go to 12.1, beginning of chapter 12. Does that mean that we can no longer turn in missing work? Okay, so yeah, Damon, that's a great question. So Damon's wondering if you can still turn in missing work. I can't really speak for everyone. My understanding is that they encourage us. It's teacher discretion, but it seems like we're being encouraged to accept late work. In my class, Damon, I'm 100% accepting late work. So what's going to happen, Damon, if you fit in this mold, in this boat, you're going to be, first of all, you're going to get contacted by me or a counselor or administration. Someone's going to contact you saying like, hey, you're not where you need to be. If you don't get where you need to be, you're going to have to do something at the start of next school year. So what that means, we don't know. I don't know exactly what that's going to mean. It could be something during doc time next year. Every day during doc time, you're going to have to do makeup work from this year, which I know none of you want to do. So I would take this seriously. What's going to happen is, I don't know, the 22nd. So basically starting the 22nd, we're going through a process called remediation. Each class might have different remediation. Some classes might have assignments they're going to give their students, and their students are going to do the assignments to get makeup work. I don't know. I might be doing that. I'm not sure. We're having a math department meeting tomorrow, so we're going to have to talk about it. But one thing I am doing for sure is I will be accepting any late work. So Damon, let's say you missed Alex 8.3, whatever. Let's say you missed that assignment. You got to tell me. I'll open the assignment up for you. You'll have time to get it done. You'll email me when it's done. I'll put your grade it like normal, update it. No punishment for being late. So this time, this remediation time, which is going to be, I think, 2 weeks. Let me see the calendar real quick. It's from starting next week until the end of the school year. So I think you're going to have 1 week, I think 2 weeks, I want to say. So you have 2 weeks to make up any missing work in my class. My plan right now is to not give any like extra assignments, like as extra credit or, other remediation assignments. That's not my plan. My plan is just to have I give you assignments for a reason because I want you to do them because I think they're beneficial. So if I really want the people who aren't doing any work to get the most out of it, my plan is to have them do the assignments that they were intended to do in the first place. So I'm gonna make posts in Google Classroom. I'll email specific people depending on who you are and your situation. We'll get it together. I'm gonna get more information. We have a staff meeting today and then a math department meeting tomorrow, so I'll have more information. But a lot of you guys don't have to worry about it. It's until June 9th. Yeah, so 2 weeks. Okay, so yes, moral story is a lot of you guys are you could potentially be done after this week in all your classes if you've been up to date on your work and you're doing well. So it's pretty cool. Anyways, let's look at this week. So this is the calendar for this week. Upsetting, this is my last week to teach you guys, but, I think it's been a long year. I'm sure we're all looking forward to summer. So here's what we got going on. We were kind of in a weird spot right now because last week, if you remember, we finished Chapter 8. So we did like a review of Chapter 8. We got really in-depth with that. Got a ton of content out of Chapter 8, and I think that was really good. And now we're done with that, so now we got to move on. Well, the way I saw it was I'm not going to start a brand new Algebra 2 concept you haven't learned before and just give you 2 days to talk about it because it's going to be a waste. You guys won't remember it. It's not going to be I don't know. I just don't think it would be worthwhile. So what I did instead was I went through and I said, okay, what unit has content that, first of all, you guys have already seen before. So it's not brand new. It's something you've messed around with before. That's number one. Then number two, something that's going to be ultra important to any math you take from here on out. Okay? And that chapter ended up being 12.1. That's what I decided to pick. So we're going to spend this week and we're going to do 12.1. We're going to do 12.1 notes today and Wednesday. You'll have an Alex assignment and then a Khan Academy assignment. Those will be the last 2 assignments in the gradebook. As far as I know, there might be some extra credit opportunities. I'm not really sure. Again, I'll figure that out during this week. But these will be the last 2 graded new content assignments. 12.1, I didn't put a learning target only because I'm using those learning targets, multiple years. So I didn't want to put it out of order because normally I wouldn't skip from Chapter 8 to Chapter 12. So I didn't want to put it in my list of learning targets. So I didn't really put that, but basically what we're going to be learning about today is you want to have the ability of understanding right triangle trigonometry. The basics of right triangle trigonometry. So how do we find a missing angle if we're given 2 angles of a right triangle? How do we find a missing side if we're given 2 sides of a right triangle? How do we find a missing side if we're given a side and an angle? All that good stuff. And this is stuff you guys learned in geometry. You might have dreaded it. You might be thinking oh, Mr. Harris, the last week of school, you're going to do this to us. I knew you're the worst teacher ever, but now I'm convinced you're the worst teacher ever. I don't know. I personally like trigonometry, and it's super important to whatever math you do from here on out. Jaden, I know specifically you're going into some EHOVI woodworking. It's going to be super important. All right, you got to understand angles. Those of you guys going to pre-calc, you're going to see it in pre-calc for sure. Sine, cosine, tangent, all over the place in pre-calculus. So that's also really important. And then down the line, you get to calculus. Go to calculus 2, whatever. All throughout the maths you take from here on out. You guys will definitely be using trig. So, you know what? Mr. Harris is going to give you a week to let's talk about it. All right. Any questions about you guys have any questions about the conversation we've had about the remediation process after this week and what the plan is? Again, I want to specify I'm not I will not be streaming after this week, so this is the last week I'll be streaming. So you guys won't have to like wake up and be here at 11 o'clock, even though not a lot of you guys do anyways, but no new content after this. I'm going to work on potentially, like, certain people I understand will want some help, and I'll work on maybe going streaming live for certain students if they ask me, and if we can get to an agreement. I don't think it's going to be like a set time. I'm not going to say, hey, I'll be on 11 o'clock, hop in. It'll probably just be on an individual basis. Again, though, like, future Mr. Harris has to get more details on that, so I can't really say anything definitively right now. All right, so 790 is the page, by the way, Jaden. So go ahead in the chat, give me like a okay, good, thumbs up, something when you guys are there and open. Have your notes out, ready to go. Thank you, Jaden. Thank you, sir. Okay. So, title, trigonometric functions in right triangles. So here's what we want to talk about. Here's what I want to talk about, guys, because I actually don't know, and I'm curious. When I say trigonometry, what's some things that come to your guys' head? Anything you remember from trigonometry? Give me some buzzwords, some phrases, a formula, whatever you remember. What do we know about trigonometry? Opposite hypotenuse. All right, there you go. Very good. What else we got? I think of triangles. Perfect. Great answer, Jaden. So you keep going. Damon, you got anything? When you see trigonometry, think of these triangles. Sarah said opposite hypotenuse. What does that mean? Side lengths and angles. Very good. All right. Putting some stuff together. Angles of incline. Okay. That's a good one. Anyone have a theorem that we talk about a lot with trigonometry? Can anyone think of a theorem? Very, very popular theorem. One of the most popular math theorems, I would say. Angles and measurements. Yeah, good, Damon. Exactly. That's what you should be thinking of. So a theorem that maybe deals with side lengths of a triangle, a right triangle. You guys remember that? Super popular. I think you had learned it last year. I would assume you did at some point in your math journey. I think you've learned it. Pretty difficult to spell. Cosine, that's not a theorem, but that is a property. Pythagorean theorem. There you go, Digidio. Yeah, Pythagorean theorem. A squared plus b squared equals c squared. That's a huge part of trigonometry. Something very useful to us. All right, cool, good. So yeah, you guys have a pretty good memory then of some stuff that you talked about. So this unit, this chapter, again, like my intent was not to teach you brand new things. My intent is just I want to refacilitate trigonometry, which is such an important part of math. So I want to review it, like make sure it's like just really solid. So this week might be in general very, very easy for you, and that's okay. Like my intention was not to make this a hugely difficult week. It's to help if you forgot about this stuff because it's important. All right, so I like to read these. I'm going to read these again. So we got a cool little picture somewhere that I wish I was, right? Look at that beautiful blue water. Let me set the scene. You're in beautiful blue water. Speedboat flying down this body of water. I'm guessing it's an ocean. Some person in this, what are those called? Hang gliding? No, I guess it's not hang gliding. Some sort of gliding attached to that boat, just soaring above the beautiful water with the birds, enjoying his or her life. That's the scene we got going on. Parasailing, that's the word. So it says the altitude of a person parasailing depends on the length of the tow rope. So this is the tow rope right here. They express it as this little L. That's how they represent that. And the angle the rope makes with the horizontal is x naught. Now, don't worry about the variables. Just saying, like, this is an angle that makes with the tow rope and the person. Right here. If you know these two values, you can use the ratio to find the altitude of the person parasailing. The altitude, or I guess you could say A, is just from the body of the water directly perpendicular up. So perpendicular with the water, a line that goes straight up to the person's feet. That's the altitude. That's how you measure the altitude. So it's interesting, like, here's the way I kind of see it. You know, if you really need to know this information, which if you own a parasailing company, you probably want to know this information. There's probably like ideal angles this has to be in order to get the best experience parasailing, right? You don't want someone to be straight above the boat. You don't want someone like on the water, right? Just like parasailing with their feet hitting the water. That could be dangerous. So like you want this angle to be probably around a 45, I would guess, would probably be a good parasailing angle. I don't know. I'm not a parasailing expert, but I would say that's probably good. So you know what your rope length is. You always know what that's going to be. Right? And there's tools you could use to find an angle with whatever the person is. All right, and so if you can find both of those easier, then you get the altitude. Because there's no way for you to get the altitude. There's no way that you have, like, unless this person is chilling up there and, like, just drops a, like, tape measure down and, like, somehow, like, finagles away. And, it just, like, finding the altitude is going to be difficult. Nowadays, they probably have, like, smart watches, though. You probably could just, like, look at your watch and it'll tell you how high in the air you are. And knowing the technology we have today. But my point is it's kind of interesting to know that, like, we always know the rope length. We can find the angle based off of those, but then we can find how high up the person is. Which is something cool that if you're parasailing, you will probably want to know. You probably like go back home to your mom and dad, and you're like, guess how high I was? Yeah, I got 50 feet in the air. It's pretty sick, mom and dad. So yeah, that's trigonometry. That's all trigonometry. And this specific trigonometry, maybe you're thinking to yourselves, like, oh, how would we do that? Right? It doesn't tell us how we do that. And all of you guys, all three of you, kind of mentioned it has to do with angles and measurements. Okay, and like Jaden said, cosine tangent. Sarah said opposite hypotenuse. All this kind of put together, we have this adage called SOHCAHTOA, this mnemonic device, SOHCAHTOA. And I'm going to write that down on my paper in a second. But that's what we would use. We notice that altitude is opposite of my angle, and then I have a hypotenuse is given to me. Hypotenuse is directly diagonal from the right angle. So right angle is here. That's what that little box is. Hopefully you guys remember that. The hypotenuse is directly diagonal. So I have a hypotenuse, I have opposite, or I'm looking for opposite, I have hypotenuse, so that's going to be SO, or sine. opposite over hypotenuse. That's how we would solve a problem like that. All right, moving down a little bit. So trigonometry is the study of relationships among the angles and sides of a right triangle. So just like you guys said, a trigonometric ratio compares the side lengths of a right triangle. A trigonometric function has a rule given by a trigonometric ratio. The Greek letter theta. So take a look at that real quick, because I know you guys probably aren't as, I'm sure you used it in geometry, but it's not like a super familiar term. This is a lot of times in math, especially as you guys get farther and farther in math, Greek letters are used a ton. They like, especially with angles, and I think that's kind of a real reason they do it, is because they want to decipher angles from side lengths. So you'll see side lengths are usually measured by letters, A, B, C, D, E, F, G, and so forth. Angles are usually measured by Greek letters. So theta, beta, alpha, all those good ones. And theta is specifically the one that people generally use for angles. So you'll see a ton of angles being represented by this theta. Like I said, I'm sure you've learned this before, but it's good to know. Okay. The hypotenuse, the leg opposite of theta, and the leg adjacent to theta are used to define the 6 trigonometric functions. So we have 6 trig functions. All right, and I want you guys to copy these down because this is going to be a good reminder, a good little review. So look at this right here. If theta is the measure of an acute angular right triangle, then the following trig functions involving the opposite side, the adjacent side, and the hypotenuse are true. All right, so I'm going to flip over to my camera here. So we got 6 of them. So we're going to have sine of theta. Let me get my... These are the main ones. Cosine of theta. No. Oh. And tangent of theta. Okay, so how do we remember these formulas? So you guys, I think, are good with actually knowing what they are. But this is how we look at them. So sine, we say so. I'm going to spell it out actually on the side. This is where SOHCAHTOA comes from. So sine is so. Notice they both begin with an S, right? So, sine. SS. Ca, C-A-H, they both start with a C, so you know it goes with cosine. So, ca. And then toa is where we get this T from. And. Thing is it being weird, but. So, SOHCAHTOA. Sine, cosine, tangent. Now, what we use to actually get the rest of it is the next 2 letters. So the beginning letter is just to tell you is it sine, cosine, or tangent. The next 2 letters tell you what the ratio is. So what the trig ratio is. O and H with so. O and H represent opposite over hypotenuse. A and H represent adjacent over hypotenuse. So the A is adjacent, O is opposite, H is hypotenuse. Which means TOA is opposite over adjacent. Okay, so there are more trig functions. And those trig functions are the reciprocal trig functions. So we got the reciprocal of sine is going to be cosecant. the reciprocal of cosine is secant. And the reciprocal of tangent is cotangent. I don't know if you guys have learned about these before. So go in the chat, do that now. Let me know. Have you guys learned about these before? Have you seen these? Are these new to you? Sarah says no. Okay, so these might be brand new. So guys, we learned about reciprocals. New. Okay, perfect. So we learned about reciprocals, right? Let me actually I think I can fit this. All right, so you guys might want to write this out since this is new. Write out the actual word. So that's cosecant. That's how we spell it. Co and then secant. S-E-C is just secant. And then cot is cotangent. So we might want to write all those out. So these are new to you. You guys have those. And they're called reciprocals. Why are they called reciprocals? Well, you'll notice that the actual equation that you create, the fraction is a reciprocal. So if sine is opposite over hypotenuse, the reciprocal cosecant is going to be hypotenuse over opposite. Right? We know that whenever we're finding reciprocals, we just flip the fraction. So if we're finding 1/5, we want the reciprocal, it would be 5. We want the reciprocal of 2/3, it's 3/2. Not opposite reciprocal, so the sign's not changing, just the reciprocal, just flipping the fraction. So the reciprocal of cosine is secant. So you flip, instead of adjacent over hypotenuse, it's hypotenuse over adjacent. And cotangent's the reciprocal of tangent, so instead of opposite over adjacent, it's adjacent over opposite. All right, so let me draw a quick picture. Remember, like I said, that little box in the corner, that's representative of a right angle. We're going to say this is theta. So that's the angle measurement I'm looking for. So as a reminder, just a review, this might be annoying, but something just to review. The hypotenuse is always directly diagonal from the right angle. We call that the hypotenuse. So no matter what the triangle looks like, it is always going to be the angle or the side length across from the right angle. Remember, we're only working with right triangles, so you're always going to have this situation. Opposite is always going to be opposite the angle that we're looking for. When I say opposite, I mean diagonal. So just like hypotenuse is diagonal from the right angle or opposite right angle, your opposite is diagonal from the angle you're looking for. So if you want to find this angle, the opposite is going to be directly diagonal. Adjacent, quite frankly, is just what the side length that's left over, right? The way to look at it, adjacent meaning it's connected to the angle. And it's not the hypotenuse. So that's just a quick reminder of how these triangles are set up. So we're going to need that. So you'll notice, right, in the parts up here, I put all these words. Now you can see where we find them. So if I was trying to find sine of theta, I would take whatever this measurement is, could be 6, and I would divide it by whatever that measurement is, could be 10. I don't know. That's how we would find our missing piece. Okay, so let's practice a little bit with this in creating these fractions. Here's what I'm going to do. An example. Find the values of the 6 trig functions for angle theta. This up a little bit. Okay, so I'm going to give you a triangle. I'm not going to use the books. I'm just going to do one of my own. Oh, I guess I should probably hold up, guys. I want this to be accurate. I don't want to just make up numbers. Give me 1 second. That's the one they use. Oh, that's the one they use anyways. Dang it. All right, let's do 14, 9, and let me see what the last one's going to be. I use my calculator. 14, and then the square root of 115. All right, there we go. Sorry about that, guys. So I want you guys to use that information. So given to you, and here's what I want our theta to be. I want that to be theta. So theta is right in that bottom left-hand corner. And I want you to take those 6 trig functions we did earlier, and I want you to solve for them. So sine of theta. Don't give me decimals. Just give me a fraction. Cosine of theta, tangent of theta, cosecant of theta, secant of theta, and cotangent of theta. And then when you're done, just go ahead and let me know in the chat. Thank you, Jaden. Give it about 1 more minute. Damon, good, thank you. Where'd Michael go, by the way? I don't know if Michael just gone silent. What happened there? Okay, so let's go over this. Make sure you can see my screen. Okay, so we're going to need to use those identities that we found earlier. That's SOHCAHTOA. SOHCAHTOA is going to help us here. So we need to find sine of theta. Okay, theta is going to be here the whole time. So sine is going to be equal to opposite over hypotenuse. So opposite diagonal from that angle is square root of 15, or 115. So we put the square root of 115 in the numerator. SOHCAHTOA, so opposite over hypotenuse. The hypotenuse is diagonal from the right angle. Right angle's here, diagonal is 14. So sine of theta is going to be equal to square root of 115 divided by 14. Cosine is adjacent over hypotenuse. Adjacent of theta is 9. Hypotenuse is still square root of 115. Usually we don't like to write it like that with a square root in the denominator, but we're going to keep it. Tangent is opposite over adjacent. Opposite is still square root of 115. Adjacent is still 9. So opposite hypotenuse, ka, adjacent hypotenuse, toa, opposite over adjacent. For these ones are pretty easy once you get these three. Notice how I wrote them. I write them like this specifically because I know that the ones next to each other are reciprocals. So the reciprocal of sine is cosecant. So all I do is I take that fraction and I flip it. So 14 divided by 115. Secant is going to be square root of 115 divided by 9. And cotangent is 9 divided by square root of 115. All right, so check your work. See if that's what you guys got. Go ahead in the chat. Let me know. How do we do? Okay, specifically Damon and Jaden, because I know you guys said you guys were done. So how did you two do specifically? You got one right? Okay, better than none. Are you guys following? Are you understanding where I'm getting these numbers from? Give me some feedback. Damon didn't get any? Okay, so there's some sort of confusion. Let me know. What part's confusing you? Did you get some of the numbers right and just the fractions were wrong? Good job, Digidio. So gentlemen, give me some feedback here. What are we thinking? Damon said, I see my mistakes. Okay. All right. Cool. As long as you guys understand where you're seeing. Biggest thing, these, you're going to get to a point where you memorize them. You may have already had to memorize them from last year, so right now some of you already might have memorized them. But these identities are super important. Now, one thing I want to talk about is the newly introduced reciprocal functions. So I'm talking about these three right on the right side there. These three here. It's super important we know what they're the reciprocal to. The biggest mistake is this. People see that sine and secant both have s's in them. So they think that these two are reciprocals. And they think cosine and cosecant are reciprocals. That's not the case. So reciprocal is opposite. Well, I mean, it's not opposite, but it's flipped. It's reversed. So you kind of want to think on the same lines. Since this begins with an s, sine begins with an s, the reciprocal begins with a c. Since the cosine begins with a c, the reciprocal begins with an s. And then this one's pretty easy because it includes the word tangent in it. So tangent and cotangent. So that one's kind of a little bit more obvious, I would say. So I usually don't see people messing those up too often. What I see is people mixing those up. So just make sure you have this picture and you make it very clear that these are going to be our reciprocals. Reciprocals. Super important. Even I make mistakes sometimes, and I've been learning about these forever, so it's understandable. All right. Last thing I want to talk about. This will help you for your homework. This should be all you need, and you guys should be able to get your homework accomplished. Is on page 791. So the next page. They talk about these reciprocal functions. I kind of hit on it. Reciprocal functions, they may mention basically you just need to know what sine, cosine, tangent are first in order to get them. So you got to find sine, cosine, tangent first. That's the moral of the story. And then from there, just understand which one's the reciprocal for which one. Okay, let's do number example 2. So you guys notice the problem we did before and all those problems from example 1. We were given all the side lengths. All the side lengths were given to you. That doesn't happen very often. Most of the time you have something like example 2, where it's not given to you. Okay, so it's not given to you. So we got to somehow work with our information. So example 2 says if sine of b equals 5/8. Let me show you on my screen, just in case. It says if sine of b equals 5/8, find the exact values of the 5 remaining trig functions. All right. So they give us the picture. We would have had to usually draw it. So number 1, guys, step 1, you always want to draw a picture. Step 1, picture. So you can draw any triangle. I'm going to draw the one that they do just because to stay consistent. But it doesn't matter like what orientation that triangle has for you guys. Just make sure that it's a right triangle. That's what's super important at the end of the day. Sorry, let me go to my camera. All right, so I'm just going to copy the one they have, but again, just make sure it's a right triangle. So I'm going to label my right angle. They tell me that sine of b is 5/8. So I need to make this, I'm going to label this triangle ABC. That's how they usually do it. It could be any letters though. And this is going to be my angle here. It's my angle B. So if sine of B is 5/8, that means SOHCAHTOA. So, opposite over hypotenuse. So 5 should be opposite that angle. So that means this needs to be 5. Hypotenuse is across from that right angle, so this needs to be 8. We don't know what this is, so we're going to label it A. Yeah, that's good. All right, that's our picture. That's all we need. So based off of this now, we cannot find the 6 trig functions. So it wants us to find the remaining trigonometric functions. We can't find them without having every side length, because we know we need the adjacent side length, we know we need the opposite side length, and we need the hypotenuse. So we need to get A. So step 2, solve for all side lengths using our lovely Pythagorean theorem. Sorry about my handwriting. I realized that I'm a little low on time. Our lovely Pythagorean theorem needs to be used, which is saying that a squared plus b squared equals c squared. Remember, our c with the Pythagorean theorem, c is always directly across from it's the hypotenuse. C is the hypotenuse. It's directly across from the right angle. So I know that I'm looking for, we're just going to say I'm going to look for a squared. It doesn't matter if it's a or b. I'm saying I'm looking for a squared because I labeled it a. Plus b squared is 5 squared. So my b, little b, is equal to 5. And that's going to be equal to the hypotenuse squared. So 8 squared. All right, and then I'm just going to do basic algebra. I would square those and then subtract the 25. And I would get a squared equals 39. Take the square root of both sides, and I get a equals the square root of 39. So hopefully you guys are thinking to yourselves, maybe you're thinking to yourselves, okay, you just found a square root. Shouldn't it be plus or minus? That's a great point. But remember what we're looking for. A is a length. It's a side length. Do we ever have negative side lengths? When you guys are out measuring something, do you ever say, oh, it's negative 30 feet? No. You might give a direction, but we don't call it negative. So our side length is just square root of 39. So we ignore the negative portion. All right, and then our final step, step 3, is just to find the other trig values. So we got our triangle, we got our lovely triangle. I'm going to replace a now with the square root of 39 back in my picture. I don't know if you can still see. Actually, you can't really see my picture, but. So we know what, in the original, so it says to find the other ones. Remember, guys, they gave us what sine was. So we have to find the other 5. So we need to find cosine of b. We need to find tangent of b. We need to find cosecant of b. We need to find secant of b. And we need to find cotangent of b. All right, take 2 minutes, 1 minute, 2 minutes. Take 2 minutes, as quick as you can. See if you guys can to find those missing angles. I got to head to work, so I'll see you later. Have a nice day. I'll see you, Damon. Thanks for showing up. Damon, also, I got your email, and I will answer that when I'm done with stream. Hey, Liberty. What's up? Welcome to Algebra 2. I'm sure you showed up because you wanted to review trigonometric functions. Understood. SOHCAHTOA, Liberty. That's the key. SOHCAHTOA. Yeah, it's funny when you revisit some of this stuff and you're like, oh yeah, I forgot about that. It feels like it's been so long since you learned it, or you just don't remember like that was even a part of Algebra 2 or geometry. How was your weekend, Liberty? What you up to? Oh yeah, how'd that go? How'd you do? Good, bad, finish where you want? Mine was good. It was good. Got to talk to my brother a little bit. He just moved out of my parents' place, so that was pretty cool to see. Moved him out to his new apartment. It was a good weekend. All right, so algebra. Let's check your work. Hopefully you got done. If not, you got some of these. So we're looking at cosine. Cosine is adjacent over hypotenuse. So I go back to my triangle. I'm looking for this angle, an angle B. I'm just going to put it in red. So adjacent of B is the square root of 39. Hypotenuse is 8, so diagonal from the right angle. So that's cosine. Tangent is TOA, so it's opposite over adjacent. So opposite of B is 5. Adjacent is square root of 39. Cosecant is the reciprocal of sine. So if sine was 5/8, then cosecant would be 8/5. You just flip the fraction. Secant is the reciprocal of cosine, so I flip that fraction, I get 8 over the square root of 39 instead of 39 over the square root, or instead of square root of 39 over 8. Cotangent, you flip tangent, so I have the square root of 39 divided by 5. Okay, and that's it, people. So it looks like I already lost some people. But if you were still from Algebra 2, that's the end of today. Alex 12.1 practice is for homework. I will be on stream again from 1 to 2. And if you guys want to hop in and work on it, well, and then ask me any questions as you go, or if you want to work on it the next hour and then ask me questions in an hour, whatever you want to do, I will be here. Stream back on Wednesday at 11. We'll be finishing up Chapter 12, at least what I want to finish up from Chapter 12. And that'll basically be our week. So, hope you guys have a great rest of your day. Thanks for stopping by. All right, pretty good. I broke to the top 64. Okay, that's good. And then dropped around. Oh, all right. But it was brand new form of debate for me. Yeah, I remember you saying that. This wasn't even like anything that you were like super like in your wheelhouse. So, I mean, you should be pretty proud of yourself. Breaking top 64. I mean, I don't know the statistics on that, Liberty, but I got to imagine if I were to look up how many people are in your event in the nation, and for you to be able to say that you're one of the best 64 in the entire country, I'd be pretty proud of it. Like, don't look lightly on that. I know you're competitive and you would love to try to break even higher, but that's pretty awesome. Takes a lot of skill. Thanks, Jaden. You have a great day too. Appreciate it. So Liberty, I didn't hear anything really. I know Mr. Snook, he said something about it, but how did they do it? Did you actually go somewhere? Liberty, I don't know if you're still there, but if you had, I don't know if you had a question specifically for me or whatever, but I want to make sure you're still here. So I don't want to end the stream. I didn't know if you were maybe typing out something. I know sometimes the connection can get a little weird.